Hello guys, how are you today? So today I'll be explaining the Math Geometry Periodic Course Practice Quiz of section 4.8. So let us start with the first question. When we are dealing first of all with chapter 4.8, we have to read very well, because if we don't read very well, we will do mistakes if we don't read very well. So from a lighthouse, ship A is at a distance of 6 radical 5 miles and on a bearing of 40 degrees. Okay, so from a lighthouse, this is what our basis. We are gonna say this is the lighthouse. Let me draw a straighter line. Okay, this over here is what? This is our lighthouse. We are gonna call it L. Now we have ship A. What is wrong with ship A? Ship A is at a distance of 6 radical 5. Before we draw it, we're gonna say it's at a distance of 6 radical 5 miles and on a bearing of 40 degrees. Okay, so let us say a bearing of 40 degrees. What does a bearing of 40 degrees means? Very simply, it means that at an angle of 40 degrees from the line passing through the lighthouse. Okay, or the line perpendicular to the lighthouse in a sense, or which is the lighthouse. So this line over here that you drew, which is the straight line, the bearing of 40 degrees means it is gonna be 40 degrees from the lighthouse line, or the one that denotes the lighthouse. And this over here, I'm just gonna make this smaller. This over here is gonna be what is gonna be ship A. Now, it is at a distance of 6 radical 5 miles. That means this over here is 6 radical 5 miles. And ship B, they told us, now we have another ship, is at a distance of 12 miles and on a bearing of 310 degrees. A hint I will personally give you: if it is greater than 180 degrees, directly do 360 minus the angle, and you are gonna get what? You are gonna get 50 degrees. So you are gonna do 50 degrees, but you're not gonna do it from the counterclockwise side. No, you're not gonna do it from this side, which is the clockwise side. You are gonna be doing it from the opposite side, which in my case is the counterclockwise side. So it's gonna be something like this. And it has a bearing of 310 degrees, or in our case, because we did it from the other side, it's gonna be 50 degrees. Okay, so let us say over here is what is ship B. They told us it's at the distance of 12 miles, so this over here is 12 miles. Now they want us to find the distance between the two ships. So the distance between ship A and ship B, they need us to find it. Very simply, if you remember from the previous quiz, if we have two sides and an angle in between them, we can find the side opposite to the angle by applying the cosine rule, which is 12 squared plus 6 radical 5 squared minus 2 times 12 times 6 radical 5 times cosine of 90. But I'll give you a little trick here. I used cosine 90 because I added these two angles together and we got 90 degrees. But it's 90 degrees, it is a right triangle. So instead of doing all of this, when in the exam you get a right triangle, like in this case, we are gonna do what? Just apply Pythagoras theorem, which is 12 squared, or side squared, plus 6 radical 5 squared is equal to what? Is equal to the side, which is from A to B. We are gonna call it AB squared. So 12 squared plus 6 radical 5 squared. Please be careful how you put it on the calculator, because it might take it wrong. You are gonna get 324. Then do radical 324. You are gonna get 18. And so then our answer is gonna be 18. Moving on to question number 2. A car travels from a station X to a station Y 460 meters away on a bearing of 210 degrees. Okay, they told us we have a car travels from a station X, which is the original station. We are going to say this over here is what? Station X. It travels to station Y, which is 460 meters away, but on a bearing of 210 degrees. Remember, actually, we can do this question in many ways. So, remember we said if the angle is greater than 210 degrees, we should do 360 minus 210 degrees. So we are then gonna get 150 degrees. So it's gonna look approximately something like this. So this over here, 150 degrees, and this is 460 meters of length. They need us to calculate what? The distance due west. So what does that mean? If I continue the line x, I make it a straight line. They're saying the distance due west, or the distance that goes to this direction. Okay, so if I also continue the line y, we will see that it makes a triangle with the line x and the distance due west. If you don't remember it, just remember, never eat shredded wheat. North, south, east, west. So west is gonna be to the left, okay? We have a side over here of 460 meters and an angle from outside which is 150 degrees. But because x is a straight line, that means what is left for this angle over here? It is 30 degrees. Now, how do we find this side over here? Very simply, we are given what? The hypotenuse. How did I know it's a hypotenuse? Because the straight line made by x and the straight line made by the west is 90 degrees. So we have what? 30 degrees over here and 90 degrees over here. So that makes the 460 meters the hypotenuse. And if you remember, the so, ka, toa, okay? We have hypotenuse and we need to find what? We need to find the opposite to the angle of 30. So we are going to apply the sign. So sine of 30 is equal to the opposite, which we are going to denote as opposite, divided by the hypotenuse, which is 460 meters. So then we cross multiply, the opposite is equal to 460 times sine 30. So 460 times sine 30, which is then equal to 230 meters. Now, another way to do this is, you can do it in whatever way you understand it, as long as you get the concept correct, okay? I think I drew it too big. Over here is ship X, okay? Let us just draw it as one straight line. Now, it travels a distance from X to Y, okay, 460 meters away on a bearing of 210. Instead of doing 360 minus 210, you could do that. Since x is a straight line, you can do 210 minus 180 to directly get what? 30 degrees. But this is what? This is the distance. Here, this is, sorry, not the distance. This is the angle over here, which is the angle made from x to y. And we are given that this over here is 460 meters, so the distance from x to y is 460 meters, with a bearing or angle of 30 degrees from like what we understood, okay? And then we can apply the same rule, which is sukatoa, and we are gonna get that sine is opposite over hypotenuse, so sine 30 is equal to opposite over hypotenuse, so the opposite over 460, and then we get an answer of 230. We move on to question number 3. So let us do this again. We have a lighthouse. We are gonna call this L. Let me draw a proper line, L, okay? There is ship A from the lighthouse at a distance of 20 miles and a bearing of 20 degrees, so we can say ship A is over here. It has what? 20 miles and a bearing of 20 degrees. And ship B is at a distance of 20 miles, however, a bearing of 260. Now, whenever you have something greater than 180, you are going to do 360 minus the angle, which in this case is 260, and we are going to get what? 100. But we are not going to put the angle in where we started. So if you start counterclockwise, you are not going to put the angle counterclockwise. You are going to put it the opposite, which is clockwise. If you started clockwise like me, you are gonna put it in the opposite direction, which is counterclockwise. So you are gonna make it 100 degrees, which is something like this, counterclockwise. And this is for what? This is for ship B at a distance of 20 miles. Now, of course, this is not drawn to scale. They need us to find the distance between the two ships. Very simply, we are given what? Two sides, the angle between them, and we need to find the side opposite to the angle, so we apply the cosine rule. My apologies. So it's gonna be 20 squared plus 20 squared plus, or sorry, not plus, minus 2 times 20 times 20 times cosine the angle between them, which is 120. So 20 squared plus 20 squared minus 2 times 20 times 20 times cosine the angle made between them, which is 120, and we are gonna get 1200. But remember, this is squared, so we need to do radical 1200, and we are gonna get 20 radical 3 as our answer. So the distance between the two ships is 20 radical 3 miles. The angle of elevation of a vertical tower T, we have a vertical tower T over here, from a ship S is 17 degrees. Now pay attention. When they are talking about the angle of elevation, they are meaning the angle that is made with what? With the x-axis, not the y-axis. So the angle of elevation from the vertical tower T to the ship S, we're gonna say this is ship S over here, is what? Is 17 degrees. So it's gonna be 17 degrees from over here. Okay? Now, they told us the height, the ship is sailing 400 meters due east. Remember, never eat shredded wheat. So eat or east is where? Towards the right. So this is the direction of east. Okay, so we are gonna take all of this as the direction of east, which is what? 400 meters. Now, we can make a triangle out of this, okay? What about this triangle? They need us to find what? The height of the tower. So actually, how I would solve something like this, so how I personally would solve something like this is, because my graph looks like this, okay? I would assume that this over here would have the same height as the tower since they are parallel, okay? So we are gonna assume that this and the tower are parallel. This is just the way I solve it. If you want, I can do it in another way after I explain this. So if we find the height of this, then definitely we will be able to find the height of the tower. Now, very simply, to find the height of this, so we know based on Sokatawa rule that if it's sine, it's opposite over hypotenuse. If it's cosine, it's adjacent over hypotenuse. And if it's tangent, it's opposite over adjacent. In this case, we have what? We have the adjacent, and we are looking to find what? The opposite. So to find the opposite, we are going to be using the tangent rule. So the tangent rule says that tangent of 17 is going to be equal to the opposite over the adjacent, which is 400. So very simply, the height of the tower, which in this case is the opposite, is equal to what? It is equal to tangent 17, which they gave us to be 0.31 multiplied by the adjacent, which is 400. So on the calculator, if you do it, you are going to get 124 as the answer. Now, if you found that way a bit difficult, there is another way to do it. That's why they gave us two angles, okay? So if you find the first way confusing, we can do it in another way. We can draw a tower, again, like how we did before, this is a tower. And we can draw the angle of elevation again, which is like this, but with the x-axis, it will make 17 degrees. Now, if you don't want to use the 17 degrees, you can do very simply 90, because all of this is 90, minus the 17 degrees to get 73 degrees over here. So now you have that the ship is going east, and we know that east is in this direction because never eat shredded wheat. East is going in this direction of 400 meters. Okay, and you need to find the height of the tower. So very simply, you are gonna apply what you are given the opposite in this case, and you need to find the adjacent. So very simply, you are gonna use that tangent of our angle 73 is equal to the opposite 400 divided by the adjacent. Okay, so we are given an approximate value of tangent 73 to be 3.27. So to find the adjacent, it is gonna be 400 divided by tangent 73, which is 3.27, and we are gonna get an approximate answer of 122.3. Now this is not accurate, so I want to see what happens if we use tangent 73 itself. Again, tangent 73 itself is gonna give you 122.3. So if you use the second way, you are gonna get 122.3, which is not accurate. So that's why it's always preferable to use the first way. Okay, but if you feel comfortable to use the second way, you can do it at your own risk. So in the exam, I do prefer you use the first way because the second way will most likely give you a wrong answer, and they give you this to trick you, either to trick you or give you like an approximate answer. But please do follow the first way because in my opinion it is the better way. Now we reached something. Looking at this, you might think, oh my goodness, this is so hard, this is like, I don't know, it's a really complex 3D shape. So let us first read what they need. We are given a rectangular prism. So as a fraction in those terms, what is the tangent of the angle between the plane ADZY? So let us color the plane ADZY, okay? And the plane what? A, B, C, and D. So the angle between them is this angle over here. So I will try again. Maybe if I zoom in, it's gonna be better. Okay, so between angle ADZY, okay, and angle A, B, C, and D. Now the angle they are looking for is this angle over here. Now to find this angle over here, you can do it in many ways. You can apply cosine rule, you can apply whatever you want, but in my opinion, I prefer to apply the SOHCAHTOA rule. It's gonna be way easier for everyone and make your lives easier. So we can choose anything random. We can choose sine, cosine, or even tangent, but we have to apply on their terms. What is their terms? Their terms is that they need tangent. So if you use the cosine rule, that would be a correct method to get the angle, but it would be an incorrect result because they need the tangent of the angle. However, if you apply the tangent, which is opposite over adjacent, you are directly gonna get the tangent of the angle without finding the angle first, which makes everything 1,000 times easier, and it will like get you your answer and your mark. So the tangent of the angle is the opposite, which is 8 over the adjacent, which is 15. Now you see how simple it is to get the tangent of this angle? However, if I was to use the cosine rule, as an example, I'm gonna use the cosine rule. It's gonna be 17 squared plus 15 squared minus 8 squared divided by 2 times 17 times 15. And if you do it on your calculator, 17 squared plus 15 squared minus 8 squared divided by 2 times 17 times 15, you are gonna get 15 over 17. Now you are gonna do shift cosine of your answer to get the angle, which is 28.072. Now you are gonna do tangent of the answer, your angle, to get 8 over 15. So either way, you are gonna get the same result. You can either use the cosine rule or the tangent rule. In my opinion, the tangent rule is way easier than anything, and in both cases you are gonna get 8/15. Moving on to question number 6. This is a nice question. So, first of all, let us read the given. O is the center of the square BCDE. This is very important information. And A is vertically above O. N is the midpoint of segment ED, so N will cut this in half. If BC is equal to CD is equal to DE is equal to BE, okay, which is equal to 10, that means DE is equal to 10. That means half of it is 5, okay? And then AD equals AC equals AB equals AE is 13. That means this over here is also 13. Now they are looking for what? They are looking for the side AN. I will give you something nice. AN is what? It is a median in an isosceles triangle. How did we know it's an isosceles triangle? Because it's given that AE is equal to AD, which is 13. So it is an isosceles triangle. And the median, or the line that will make a midpoint in an isosceles triangle, is also a height. So in this case, that means it is also a right angle, 90 degrees. So if we are looking for AN, because we have a right triangle, we can apply Pythagorean theorem. We have the hypotenuse, which is 13 squared. It's equal to 5 squared plus AN squared. So AN squared is equal to 13 squared minus 5 squared. Doing it on the calculator, 13 squared minus 5 squared, we are gonna get 144 is equal to AN squared. So AN is equal to 12. And nothing can be simpler than that. Now they need us to find the area of face AED. Let us find the area of the face AED. We know what? We know that we have a height over here of 12. And we have what? A base at the bottom of how much? Of 10. So we know that the area of any triangle, very simply, is base times height divided by 2. So the base is 10 times the height, which is 12, divided by 2. You are gonna get 60. Now, the total surface area of the pyramid. This is a nice question. I like surface area personally. I don't know if you guys like it, but surface area, I'm just gonna write it in full. So surface area is equal to what? The total area. So all the areas added together. Let us go back to this shape. Let us count how many areas can we possibly have. We have triangle 1 over here. Then we have triangle 2 over here. Then in the back we have triangle 3 over here and triangle 4 over here. And do not forget the square at the bottom. So that means we have 4 triangles and 1 square. So to find the total surface area, because all the triangles are equal, it is gonna be 4 times the area of the triangle, which is 60. In addition to, I forgot how to write square. I am so sorry. Square is written like this. I apologize for the mistake in writing. So 4 times 60 in addition to the area of a square. If this is 10 and this is 10, we know that the area of square is side times side, which is 10 times 10, which in this case is 100. So it's going to be 4 times 60 plus 100, which is 340. So our surface area is 340. Now, as a fraction in lowest terms, the cosine of the angle between the two planes, EAD and BAC. Okay, I love this question a lot. Let me explain why. So, they need, what do they need? They need the cosine of the angle between EAD and BAC. The cosine of the angle EAD, okay? And what? BAC, which is what? This over here. Not this angle inside. It's from this point to this point, this angle. So, Okay, so let me explain. If this over here is our pyramid, okay? And it was like this. Let me make it in a sense. There we go. This is what our pyramid looks from atop. So I'm just gonna go back here. This is our pyramid. This is what it looks like from on top. They are telling us they want the angle made like this. So the angle made by plane EAD and BAC, which in this case are gonna be this plane and this plane. So it's gonna be not this angle over here, but in fact it's gonna be what? The angle of their medians, okay, which is this angle over here. Now very simply to find it, we are gonna go back and we are gonna calculate the sides, or we're gonna find the sides of this triangle. So NA, and let us call this side over here M, so NAM, okay. We need to find the sides. First thing, we know that this we calculated before to be 12. And since it is the same on the opposite side and they are all isosceles and the same triangle, then it is also gonna be 12. So you already have 12 and you have 12. Now, for these lines at the bottom, because they are parallel, then they are all gonna be equal. So because they are part of a square and they are parallel, then all the sides are gonna be equal. This is equal to this is equal to this. So if this is 10, then definitely this is 10. Now to find this angle made over here, we are gonna apply the cosine rule. What does the cosine rule state? The cosine rule, what is the cosine rule to find the angle? Very simply, it is gonna be 12 squared, which is the two sides. So side squared plus side squared minus the opposite side squared divided by 2 times both of the sides. You will get the cosine of the angle. So 12 squared plus 12 squared minus 10 squared over 2 times 12 times 12, if you do it on your calculator. You are then gonna get 47 over 72, and that is very simply our answer, which is 47. I wasn't typing 47 over 72. Moving on to question number 7. This is by far literally one of the easiest questions. Now, there's a difference between bearing and the elevation. So this over here is what? The angle of elevation between O and P. Whereas this angle over here is called what? The bearing. So please pay attention whether they ask you angle of elevation or bearing. They are totally different. This over here is angle of elevation and this over here is the bearing. So to find the bearing, very simply we are gonna do 90 minus 57 and we are gonna get our answer, which is then 33 degrees. So let us submit and hopefully there are no mistakes. Thank God there are no mistakes. Thank you guys for watching. I hope you enjoyed and see you in the next video and have a wonderful day.